In this video, we'll try to understand the working of the Boyer-Moore algorithm, which is an efficient string searching algorithm. So let us see how it works. We have been given an input string and a pattern. So basically, we have to search this pattern in the above input string. For that, we iterate through the pattern and we construct a bad match table. As you can see, there are two T's in the original pattern, but the bad match table has only one T. Now, we calculate the values associated with each of the letters. For that, we calculate the length of the pattern minus index of actual character minus 1. And then the values associated are max of either 1 or the calculated expression. So let's see for this first letter. Length of the pattern is 4. The index of this first character is 0 and minus 1. So max of 1 and 3 is 3. Similarly, we move to the next character, that is E. Now the length of the pattern is 4. The index of E is 1 and minus 1. So max of 1, 2 is 2. Now we'll move to the next character, that is S. So for S, the length of the pattern is 4. The index of actual character is 2. This is 0, this is 1, and this is 2. Minus 1 is 1. And now we'll see that when we move to the next character, we are finding that it's a repetition. So in such cases, we simply update the old value. So let us see how do we do it. So for the value of T, the length of the pattern is 4. Index of this T is 3 minus 1. That is max of 1 and 0. It is 1. So we update this value. This was the old value. And now we have updated it to 1. Now, this star represents any character that is not present in the pattern, and its value is taken to be the length of the string. This. So the length of this input pattern is 4, as we can see. So the value corresponding to the star is 4. Now, when we run the algorithm, we compare the rightmost character of the pattern with the corresponding input text. For that, we look into the bad match table to decide the number of shifts. So we compare the rightmost character. So S is not equal to T, but what's important is that this character S is present in the bad match table. And that means we have to shift the pattern by 1 to the right. It's important to know that we have to take the character from the text and not from the pattern when we look into the bad match table. We again compare the rightmost character. It's an empty string that is of course not present in the bad match table. And it's represented by star. That means the value corresponding to it is 4. So we shift this pattern by 4 indexes to the rightmost. Now again we repeat our steps. A is not equal to T and A is not present in the bad match table. So we take the value that is associated with star, that is 4. So we are supposed to shift this pattern by 4 indices towards right. Now we again compare the rightmost character. This time it is S. which is not equal to t, but s, as we have seen, is present in the bad match table. The value associated with it is 1. So we have to shift this pattern by 1 to the right. So now we compare from the right. T is equal to T. The next character is matching. The next is matching. And the last character is matching. So now we'll move to the pseudocode. This is the pseudocode for the bad match table. We consider every character in the pattern and keep building the bad match table. As we have seen, we can skip a lot of characters when there is a mismatch. We calculate the number of skips through the bad match table. If the character is present in the bad match table, the number of skips is the value associated with the character. Else, if the character is not present in the bad match table, the number of skips is taken as the length of the pattern. The Boyers-Murray algorithm turns out to be very efficient. When the pattern does not appear in the string, the time complexity is big O of n plus m. But if the pattern does appear in the string, the time complexity is big O of n into m, where n is the length of the input text and m is the length of the pattern. So that was all about this string searching algorithm. Thank you.